Hello, my name's Heidi Dempsey, and I'm here with Tim Up the Grove. We're from BBN Technologies, and we're here to talk about how to engineer SDN in Genie network. Genie is a virtual laboratory for people to do networking and distributed operations research and education. We started about 5 years ago, and we have been building a network of resources which are autonomously owned by different contributors to Genie. The project as a whole goes forward in yearly cycles, so people will bring new technologies, new ideas, new software into the project for a year. People will integrate, deploy, evaluate, and then we'll take a look at the end of the year and decide whether to continue or not, and whether to transition things from prototype to further use and into production deployment. Experimenters use the test bed while we're building it out, so like a lot of the networks that you build, it's being stressed while it's being used. And the people who are using it have a vote in what will stay and what will go on the network. The two things that we do in Genie as kind of the fundamentals of how we build the network are slicing the data plane horizontally, so everybody who brings a resource also brings a way to connect to the data plane, which is mostly a layer 2 data plane for the things we're going to talk about today. And then there's a vertical control plane API which you use to access those resources. This is a picture of how Genie looked when we started a few years ago. The resources that were contributed were open flow switches, servers that could run virtual nodes, virtual machines, regional networks, basically the states that you see colored in, were providing access over pieces of their infrastructure. And there were two core networks that were providing nationwide spanning connectivity. That was Internet 2 and National Lambda Rail. As you know, National Lambda Rail, or as you may know, National Lambda Rail is no longer operating, so the core of the network is now just provided by Internet 2. So what we do is take that infrastructure and slice it up by experimenters, so that people can share the same infrastructure but do completely different things, run completely different protocols and different services on it. And those slices are, as much as possible, isolated from each other with the technology that we've got to build them on. And then experimenters can actually download their own software into the network to program down to the lower levels of the switches and down to the lower levels of either the virtual machines or the hardware-based servers that they've got in the network to try new applications and protocols and services. So in order to access the Genie resources, first of all, it's open to anyone who has an interest in research or in engineering integration, so you don't have to be from a university. It's fine to be using Genie, anybody from the NANOG community or people who are interested in developing new services. That's all supported by the project and by our members and the National Science Foundation, which is our sponsor. You do need to get credentials in order to use the services, and our credential management is based on In Common, and we do shibboleth single sign-on to manage the usage of the credentials. As of last month, we have over 2,500 users who are doing experiments on and off or continuously on the network. And we span about 52 campuses, a couple of enterprise networks, but enterprises are still fairly minor in terms of what they're contributing. 11 regionals and 10 wireless sites. The type of wireless that we do in Genie is WiMAX or LTE. And then depending on the site, that might have university participants, community participants, or a combination of both. So we run these experiments continuously, 24/7, 365, and we support operations with 6 different groups around the US, each of which has a kind of a different specialty for what they do. when people find operations issues or technical issues or other issues with using the network. So a little bit about software. In order to use your credentials and access the resources, we operate a piece of software which we group together as the portal and clearinghouse. So there's a web interface to this, and there's also a programmable interface to this clearinghouse. And basically, the clearinghouse software, which is open source and publicly available for anyone who's interested in it, it keeps track of the users and the projects and the slices that are on the Genie network. So if you're sitting at your house or in your office, you can use the Genie interface, either the programmatic interface or the web interface, to create and register a slice, and that's where you're going to run your experiment. The clearinghouse will return to you your credentials to use for that slice, and then you interact with the places that have resources using an aggregate manager API to both provision and control and use those resources during the course of your experiment or your integration or your trial or whatever it is you're running on Genie. So there's some links in here to the software in case you want to take a look at it, and to the API definition in case you want to see how the common API works. The places where you can get credentials to use in Genie right now are, of course, the clearinghouse itself, a Planet Lab account, if you have a Planet Lab account that is federated with Genie, or an Emulab, or as it's sometimes known, a Proto-Genie account. Now, engineering for a layer 2 SDN. Genie's objective is to let experimenters run their own SDN controllers. So this is different than a lot of networks that probably folks in this room would be involved in, because we specifically want to give access to people at the lowest layers. In addition, people who operate networks can run their own controllers. So an SDN switch will support multiple controllers operating at the same time. At least most of the vendors will support that. And so operators may choose to run a controller, and then experimenters run secondary controllers on top of that. What we do in advance is go into the SDN switches and the endpoints on the network and configure VLANs that are available to be used for OpenFlow and VLANs that are available to dynamically make connections between endpoints. The three types of configurations that we found useful are dedicated VLANs, where you have one VLAN that connects to all the resources in the Genie network that are part of an experiment. And those are all controlled by one OpenFlow controller. Or a shared VLAN, where you use that VLAN to connect multiple resources, and then you can have multiple people running controllers to share control. An example of this might be one person might want to use SDN for the application, another person might want to use SDN to bring nodes into and out of the experiment over time based on demand. And so you'd be running multiples. Another thing that's useful for us as operators is you can run a controller that you can use to look at what's going on in a slice. So even though the infrastructure for Genie is pretty well-defined and not as dynamic as SDN can be with a controller, you still need a view into each one of those slices if there are problems with those slices. So shared VLANs are good for being able to look at what's going on in a slice without being destructive. And then finally, for some of the WiMAX and LTE applications, we use multi-point VLANs that connect all of the wireless sites so they can do handoff and interesting experiments with multi-point. Experimenters in Genie can choose to work with hardware switches, or they can choose to work with software switches. Software switches are a lot faster to come up to speed on. We're only going to talk about hardware switches here, but if you're interested in software switches, come up and talk to us afterwards. The Genie Aggregate Manager software negotiates and coordinates the resource access. So these are the links to go to if you want to see how the VLAN stitching works. And again, this is all open source interfaces and open source software. And then there's a special aggregate just to manage OpenFlow, which we call foam, and this is the link to foam. The primary purpose of foam is actually not to control the VLANs. It's to allow people who are opening up their resources to OpenFlow to have the opportunity to approve or not approve connections into their resources. So you can use the foam aggregate manager software to define patterns that you're okay with approving, or to look at every single request and individually approve those or not approve based on what's happening with the SDN. So this helps with some of the fear and uncertainty of people who are just getting into SDN. So this is an example of one of the networks that we engineered for a particular experiment. This is showing the core network with different SDN switches in the middle of the picture, and some Genie racks. I'm sorry it doesn't look so great on the projection, but if you look at it in the slides, you can see the details about the interfaces and what we were doing with this particular network. We support lots of vendors in Genie. We explicitly want to be interoperable. We support interfaces from 1 gigabit to 100 gigabits. There's no SDN interface that operates at 100 gigabits right now. The highest you can go is 40, but we share links with other research programs, so that's why the 100 gig is on the list. One thing that's interesting about our network is we're still running on OpenFlow 1.0. And those of you, I guess everyone in the room who's been assaulted by the OpenFlow hype, you would think that everyone would be running OpenFlow 1.3 by now. But it turns out that when you're trying to do a multi-vendor network and you're trying to work with a lot of network aggregates, 1.3 is still early on in development, even though it has a lot of great functionality. So we're still running at 1.0 and hoping to move ahead with 1.3 later in the year. We use standard internet for our control plane, so all the benefits and disadvantages that go along with that apply to our control plane. But so far it's been working well. And then we use 2 services from Internet 2 for cross connects. One is called ION, which allows you to create and destroy VLANs to connect you to that core network. And another is called the Advanced Layer 2 service, which is another way of making connections on Internet 2 kind of at a higher speed and dynamically. So this is a list of the vendors that we support. Some of these vendors have multiple kinds of switches on Genie. If you're interested in any particular ones, again, come talk to us after the break. Open vSwitch is a popular software one that we see, but there are other popular software switches as well. These are the 3 popular controllers that we see on Genie: Floodlight, Pox, and Open Daylight. I think Floodlight and Pox are probably quite a bit more popular. And then operators on Genie are contributing software. So operations in SDN is still a very active thing that we're trying to figure out and do collaboratively with other system engineers and network engineers and administrators. So a lot of those are listed on genie.net, but we'd love to get more. Things you have to watch out for when you're running an SDN network. You don't want protocols that aren't SDN affecting what you do for routing and forwarding. So you have to disable spanning tree protocol and disable MAC learning. And this is very simple to write and very hard to do. Tim spends a lot of his time talking to people, trying to explain to them why they need to do that and figuring out how to do it on every type of switch there is out there. Because you need to do it on the whole path and not just the SDN switches. Places that are doing commercial SDN might not have to be quite as extreme about that, but because we're doing experimentation, we have to be very pure about it. You have to coordinate your IP addresses once you've connected everybody up on a VLAN, make sure people aren't conflicting in their choices of addresses, especially when you're using shared VLANs. That really hasn't been an issue yet, but obviously with scaling it could get to be a problem. We have some operations tools to look for loops and to look for heavy loads on switches and also on the processing nodes in Genie, and ways of limiting traffic externally if needed. most of the support for limiting things in SDN switches is still very early on and not really something you can rely on if you have to cut something off quickly. Another thing to watch out for is you need to compare the firewall rules in the data plane. This is just like regular networking, except the SDN rules, since they allow you to change things in the header, more things in the header than might change in a normal IP network. You have to make sure that you've done more checking with the firewall people who administer things that are in your data plane, and even things that are in your control plane if you're supporting the API, the standard API in Genie. And the last thing to notice, probably most of you who've touched SDN already know, but this is a major thorn in our side, is partial implementations. So almost everybody who does an SDN switch still does a partial implementation. And if you're making an interoperable network with 6 or 7 different providers, you're laying those all over top of each other. And sometimes it's really hard to find an end-to-end path that will work with the particular types of modifications that different people want to do in their packet fields. So you have to keep a careful eye on that. So here's an example of a real live experiment that we ran and real live problems that we had. And Tim is going to tell you what happened one exciting day when he woke up and found that there was an issue on Genie and spent quite a while trying to track that down. So Tim, what was it that you saw that led you to believe that there was an issue in this network?
So can you move on to the next slide?
Yep.
So the previous slide was kind of showing the paths that we had to deal with, the layer 2 paths, and this particular slide is more so showing the active monitoring that we were doing. And you can see the test points attached to some of the, going off of some of the core nodes. And we could tell that some of the traffic following the blue line from that the BBN node up in the top right corner was not getting through to the test point in the Seattle node. And it was kind of a sporadic drop. So, I mean, the sporadic problems are always fun to deal with. And we also saw a couple of problems with the Chicago, the test point hangoff of Chicago, but not quite as many. And we also had another operations group who was actually has a little bit more access to those switches, and they were getting CPU alarms for the Denver switch. So it was pretty clear that something was wrong, and it seemed highly likely that whatever was causing the CPU problems on the switch was also resulting in the traffic drops we were seeing in the data plane.
So next step is trying to isolate the problem. What did you do for that? We didn't rehearse this or anything.
No.
The next one?
Yeah.
Sorry.
So we went through this sort of nice little diagram here, although of course when you have your problem in your network, the problem space is more like the world, and you have to kind of constrain it down. So it wasn't quite this simple. It wasn't just following the path, but we can do that now. So like I said before, we assumed that there was a correlation between the high CPU usage on the Denver switch and the problem that was causing traffic to get dropped in the data plane. And so at that point, we were just trying to figure out what was causing the high CPU usage on the switch. And just having dealt with this in the past before, typical problems might be somebody was overwhelming the control plane by sending too much traffic to the controller or injecting a bunch of traffic into the network from the controller. The switch CPUs, they're still not that high grade, so the agents that are running the OpenFlow process can sometimes get overwhelmed by that. And we kind of investigated that for a while. We didn't have a good baseline, so it was hard to tell if that was actually the problem. But we thought that maybe, okay, this doesn't seem like it's the main problem. And so then we moved on to looking at things like the partial implementations that Heidi was mentioning. Sometimes the switches will implement a feature and sometimes they won't. But then there's a third category, which is sometimes they'll implement it in software. And that's not really well advertised through the protocol, but usually the documentation can tell you, the data sheet for the switch will tell you, this particular feature is implemented in software. So we had to go through and look at this particular data sheet and then check some of the tables in the switch and see, well, is any of this at all going into the software path? And it was kind of tough to see the obvious ones that we had seen before. Things like people doing IP rewrites, we knew that was in the software path. People flooding a lot of traffic, we knew that was in the software path. And we didn't really see any of that. So we kind of changed up how we were searching for things, and we looked for specifically which of these correspond to the software table. And then once we did that, that was a nice shortcut. We should have done that from the beginning, but once we did that, it was pretty easy to identify that there was this weird forwarding rule that was sending traffic back out on the port that it came in on, which was another thing that happens in software. So once we figured that out, it was pretty, getting to that point took the most time. And once we did that, it was a lot less kind of flailing around, but it was easy to sort of methodically go through things like, okay, well, now that we know the forwarding rule, who does that belong to? Well, we found it belonged to us, which is actually a good thing because it makes it easier to debug. We restarted our controller, which didn't help remove any weird flow rules. We restarted the Denver switch because this was affecting other experimenters, and we wanted to resolve it as quickly as possible. And that didn't seem to help either. So at that point, we took a step back, and we kind of wanted to walk through a couple of sending traffic between a couple of the test points. Can you go back to the previous slide? We wanted to send traffic to a couple of the test points, like the one in Seattle and the one in Chicago. And in doing that and kind of tracing through each hop along the way, we ended up discovering that there was traffic that was supposed to be going to this Chicago node, the test point in Chicago, and it was getting sent off to Denver. And that was kind of strange, and we couldn't really explain it. So we started, we started thinking, well, maybe the Denver switch has the forwarding rule that's doing the right thing, but why the heck is that traffic getting over there in the first place? So we start looking at the forwarding rules in the Chicago switch, and can't find anything. Double check, triple check, ask other people to check, ask the people that operate the switch locally to check. Nobody can see it. So it's this phantom forwarding rule. And at that point, it's pretty clear that we have some kind of firmware bug, and those are always fun to debug. But once we figured that out, we restart the Chicago switch. Things recovered. The Denver switch was happy again, and that was kind of the whole process. So it was a little bit interesting, yeah, I'm sure it has some sort of correlations to things that people do in here that are non-SDN, and maybe I have some interest in discussing that with people later on after.
Okay, so these are some screenshots of tools, open source tools that we use to look into this problem and other problems as well. I'm sorry they're really hard to see, but if you download the presentation and you want to look at how you can find open flow tables and flow stats, these actually match with the example. And also the Wireshark open flow tool is really helpful. Anything you want to say about the tools?
They're probably the same tools that you use every day. They just have, the Wireshark has a special dissector for OpenFlow, and all the other stuff is going through REST, so it's just, curl and, formatting, so.
Yeah, you have to write a little bit of scripting and dealing with it, but it's worth it. Okay, so I'm not going to pick on a particular vendor, but I will tell you HP is a great vendor. They're a big partner of ours, and this is a picture from their document. And the reason that I'm putting it up is to illustrate what we were saying about the complexity of the rules in SDN right now. So this is a match by the piece of the packet and the flow type that you'd like to work on, and the conditions for any one of these things that are blocks to actually be successful. Each of these has limits on it, and each vendor has a different table. A lot of the tables aren't actually published by the vendors, so the fact that I put HP up there doesn't mean we think HP is bad. It just means they did a better job of documentation than a lot of other people. So if you take this kind of complication and then you add multiple vendors, you get an idea of why working on SDN is really fun. It's a great engineering challenge, it's a great operations challenge, and it's early enough in its development that I hope it would be interesting and appeal to a lot of NANOG members. Things that we're thinking about doing next with this in Genie, as I mentioned, we expect to migrate to 1.3. We expect to see better support for hybrid networks. That means single switches that will support both OpenFlow and non-OpenFlow flows in the same switch, so isolated by interface or perhaps by VLAN. It's done differently for different vendors, but we're getting to the point where hybrid networking is a little bit more of a reality than it was in SDN probably 3 years ago, where it was talked about but not really done. And that's especially important for deployment, because if you've got one piece of hardware that can do both things, then you've got more resources that open up to you as being things that you can try using SDN for. We have a software project to separate the network slicing by VLAN from the rest of the SDN control functions. And it's not just only network slicing by VLAN because we're doing it in an open flow environment, but instead of having everything in one piece of software, which was the original FlowVisor software that came from Stanford, we're kind of trying to modularize functions into different pieces so that that's easier to manage and upgrade and fix. We're also entering the dreaded phase of policy management. Again, this isn't a problem that's unique to SDN. Lots of other networking people have dealt with it. But once you use SDN and you have the ability to change what's happening with the packets in flight, you have perhaps a little bit more variations in what you need to consider for policy management for people who want to connect. That's just starting up this year really seriously as a software and technology effort. We're seeing SDN start to show up in some of the broadband and home networks. Nick Feemster, who's spoken at NANOG before, is involved in some projects like that on Genie, and it's starting to show up in some of the metropolitan areas. So that's exciting and new, especially for the folks who want to do application development in homes. We're seeing people start to work on SDN exchange points. There are 2 of those that are under development now. Right now, they're just between research and engineering organizations, but there's talk of being able to branch out from that. One is centered in Northwestern, and one is centered in Georgia Tech. So if you're interested in either of those things, let us know. We'd love to have more participation from people who have had experience with this stuff in NANOG before. And of course, you need cross-domain monitoring if you're going to run cross-domain protocols. And because of what Tim was talking about how you really need to look into the slice, especially at this stage of open flow development, to see what's going on, you need monitoring tools that allow people to share that information. You don't want to just open up everything in your network to other SDN providers, particularly if you're in a competitive commercial landscape. But you need a way to share information that everybody needs when they need to debug something like an SDN exchange problem. So this is a little picture of an architecture that we're trying out in Genie. We sort of have a standardized process for deploying and testing SDN nodes in Genie, and I put some links into those if people are interested in coming up to speed and participating. This is the last set of things that we do to kind of standardize and make the SDN stuff possible to manage. We document all the tests we do. We document the network. We run SDN gear through acceptance testing to make sure it'll at least do the basics of what we need to put SDN paths across different resource providers. And all of this stuff is available on the website if you want to see more details. So with that, we're open to questions.
Hi, Ralph Mullen, Internet Archive. I participated in 2 Genie experiments establishing a virtual circuit between California and Ohio. It worked, and I fully anticipated that I get to know every network admin in the way to debug it. What I didn't anticipate was that I kind of also needed permission from every single network operator in between. And it reminded me kind of the bad old days before packet switching, when you had to get a circuit from the phone company. Is it too late to bake openness in the architecture to be by default permissive, be by default liberal in what you accept, so we don't need permission and can just experiment?
Well, I'll say my opinion and then you can say your opinion. I don't think it's too late at all. I think we've been trying to get that pre-provisioning and that allocation step to be separated from when people use the network. And frankly, we've been running so fast that there isn't much of a delay. a lot of the time. So I think that's definitely a goal, and the administrators are getting more comfortable with it at the endpoints. And so if we can keep getting them more comfortable with it and avoid, major issues on the network, then most of them have actually done auto approval on their endpoints already. So I think things are getting better, but I definitely understand and have seen the situation that you're talking about. Tim?
Yeah, I mean, I think basically there's sort of two phases here. The first phase is the provisioning, and then the second phase is the experimentation. The provisioning typically does take a long time, as you pointed out, but once it's there, the experimentation should be pretty simple. It should be, it just works. But the bootstrapping problem is there of getting connected if you have a new site that you want to plug into Genie.
And
Yes.
last question over in this mic.
Dan McGrayan, Johns Hopkins Applied Physics Lab. So, a lot of operators are very skeptical about SDN. We were having a very vigorous discussion about this over lunch yesterday, a bunch of us. I get that Genie, is an NSF-funded, test bed that's run by BBN and, layered on Internet 2, dynamic VLANs, sure. And, but what a lot of, and everybody understands the, the well-documented use cases of, building terascale data centers, yep. Having strange protocol research by your grad students, yep. General test bed for doing weirdness at layer 2, yep. Everybody understands those things, but what's really missing in a lot of people's mind is compelling use cases, and you really kind of, you had a slide in there in which you glided over a couple of them without really going into them. And I get it, as BBN, you're the operators of the test bed, and it's not your experiments, but and also you had the debugging stuff of like, okay, here's how I debug something where the traffic flows all go south, but sure, what were you trying to do in the first place? Sure, we all have to debug problems, right? But what was it you were really trying to accomplish? And that's where people really get very skeptical. I mean, so, it kind of tends to fall into the religious camps of people who are either firm believers in DIY, and they really want to write everything themselves, and they have, operators should have strong programming experience, all that kind of stuff. And people who are like, and the other issue is from a vendor perspective, SDN is simply turning into an API, They're sort of saying, well, you don't have to rip the protocol head off your switch and write your own stuff anymore like you used to with OpenFlow. These days, you can have your cake and eat it too, right? You can run your standard switch, our switches, and do all the standard stuff you're used to doing, and then if you feel like doing any of this extra programming, well, then that's just an API too, right? So that's kind of where a lot of, vendors see SDN going to. So I wonder if you had any comments
I think,
all that.
Yeah. So I think you're right about the applications development. The kinds of things that I've seen that are the most interesting on Genie for applications, which you're right, I didn't cover in great detail here because it's not our specialty, are people at campuses who were using SDN to find and capture interesting things on laptops that they wanted to kind of be able to isolate and do something special with. There are other technologies that you could use for that too, but they were able to do it with SDN kind of easier and faster than with 3 or 4 different special purpose vendor tools. And then I think there's been a lot of interesting stuff happening with handing off SDN between different organizations, and we're just in the early phases of that. So again, that's interesting from a network person's point of view, and it's interesting to run an application that has an endpoint in Japan and an endpoint in Europe and a few people in the US participating, but I wouldn't say there's a killer app there yet. Tim?
Yeah, I agree. I think a lot of the cases where I've seen where it had value would be things closer to the edge where it's not risky and maybe you need to do something specialized, or really just in general special cases where you want to do something that's more standard. I'm going to give the prototypical SDN example, which is what Google does with their backbone stuff. They're doing BGP, but occasionally if they want to do some traffic engineering stuff, they can just toss that in and it's easy for them to do, I guess. So I think at this stage, it's more about looking for cases where you want to augment what you have today. And again, this is another bootstrapping problem where that code doesn't exist, and as an operator, you probably don't want to go and write it yourself. But I also don't think that, I think that part of it is opening up an ecosystem such that it's not just the incumbent vendors that can come in and write that for you. It could be anybody, and as long as somebody's tried it and they say, oh well, this is pretty good, then maybe somebody else will try it. And if that gains some traction, then it kind of opens up the space to other smaller vendors to give you some code that you can run yourself. And as an operator, you don't have to just go and write it all from scratch. So that's kind of my view, at least.
Yeah, I mean, this is a conference of operators, right? So I think I personally would have enjoyed your talk a little more if you had, instead of saying, here's our test bed, if you'd led off with like, okay, here's a bunch of things that people have done on this test bed that have actually found their way out in the real world and aren't just of interest to academics, kind of thing. But that's just a suggestion.
All right, last question at the mics here before we cut to the next presentation.
Hi, Paul Knifick, Epic Technologies. I just have kind of one question playing off the previous comment. I understand that your technology can be used by both academics and third parties that register. My town recently just got a Genie rack in Flint, Michigan. My question is, do you provide services for commercialization for third parties, or any assistance with commercialization of technologies developed on your platform?
NSF is explicitly supporting people who want to do prototype transition to commercialization on the Genie network. They think that that's a good thing. They want people to have partners who are involved with research. It's not hard to find partners. You can come to a Genie conference. You can actually get support from NSF to come to a Genie conference, and there are a lot of people who would be interested in working with anybody who wants to try this out for any reason, even if it's leading to horrible commercialization.
Great. I was just trying to make the distinction on if this was purely in the academic realm or if there were
No, it's explicitly open to other people, startups, things like that. We don't want you to use the Genie network, obviously, to support an existing service that you're already paying for and try to run it on NSF connections for free. But as long as it's not something like that, and you have a good case for engineering integration or research, then it's likely to be allowed on the Genie network. We use other people's networks, so we just have to make sure we don't violate their rules, but the rules are pretty tolerant, and we intentionally did it that way.
Great, thank you.
Sure.
All right, that's it.